Just to recap, Doubleword.ai helps to batch your inference load against open source models with a huge cost reduction. In the previous video, we discussed how we can use Doubleword.ai to schedule batches. In this video, we are going to look into a practical example where we're going to batch a huge data set and process it with Doubleword.ai. For this, I'm going to use the invoice extraction example. I have done a couple of series about this invoice extraction before with OpenAI with Gwen 2.5 BL. And today, we are going to benchmark the same Cod V2 data set with Gwen 235 billion parameter model. We are going to start with the Cod V2 dataset, and then we are going to split this dataset into different batches and save it as a JSON files and upload these batches to Doubleword.ai. And then we are going to monitor for the batch status and then download the results and evaluate the performance of the model. So before we start running our code, the prerequisite for this is that you add credits to your Doubleword.ai account, and then you go to the API key section and then create a new API key, type in the name and the description, and then copy this key into the environment variable. I have already done this step. So let's go ahead and run all the inputs. We have loaded the environment as well. So the double word key, which we copied into the environment file, has been loaded. We can load the dataset from Hugging Face. I have already downloaded this dataset, and hence this as Hugging Face loads the dataset from, it doesn't take much time to load this dataset. But if you're doing it for the first time, it's going to download these 1,000 images into your local machine and then load the dataset. It might take a little bit of time. Okay, here we have the dataset with 1,000 samples. Now we have train, validation, and test. As we are going to do the batch inference, we don't need the splits. So let's concatenate all these things together. Here we have the images and we have the ground truth. Now this Cod V2 dataset doesn't have a unique ID. So I'm just adding a row index so that each image has one unique ID. So for example, let's try to print a dataset of 0. Here we can see, so each image is a PIL file, and you have the ground truth and you have the index as well. Let's move on to the part where we define the schema and the prompt. So we are going to use this schema. These are the fields of the Cod V2 dataset as such. So let's go ahead and run this. Using LLM, I have anonymized a couple of examples so that we can add these as a few short samples to our prompt. So I'm just going to run 3 different examples where you find different segments like menu, the subtotal, the total price, and other things. And then here is a simple prompt where you say like, okay, your vision language model, your objective is to extract the information from the receipts, and then you provide the requirements. And here is our schema dictionary, which talks about what are the fields and what are the meanings of the fields. And then you add these few short examples, example 1, 2, and 3 together, and then initialize this particular prompt, right? So here I have a utility function which converts the PIL to base 64. So the next step is to create the batch file. Doubleword expects you to create a batch file in very, very simple format. All you got to do is to have a unique custom ID to track back the results. As we already have the index, you can use this index to map the input and the results, and the method is always post and URL is completions. And in the body, you specify this parameter where you want to specify which model that you want to use for inference. In my case, I'm using the 235 billion parameter model. We just created a system prompt with few short examples. So let's use that as a system prompt. And in the user prompt, we are just going to pass in the image. Given ID and image in base60 format, you create a line of input and return back. So that's what this method does. Generate line. Let's initialize this. And now all we have to do is to create a batch and iterate through each of the line in this particular data set, get the ID, get the image in PIL format, convert this image which is in PIL format to base64 format, and then invoke this method generate line, which is going to return the line for us. And then you can write this inside a file. I have also added the TQDM for progress tracking. Let's wait for the completion. Okay. So we have the batch file ready. Let's go ahead and open this batch file. It's going to be a huge file. Let's just look at the size. The size of the batch file is almost 200 MB. The maximum size of the batch file in Doubleword that you can upload as a single batch is 200 MB. So as our batch size is 196 MB, we can directly upload this in one shot. But still, the better way to process this is by splitting this into multiple batches, because imagine we are splitting these 1,000 samples into 10 different batches and each batch containing 100 images at one shot. It's going to help to run the inference even faster, because once you upload these 10 batch files to Doubleword.ai, is going to process everything concurrently. But that's okay. We have written all these invoices into a single batch for now. Let's go ahead to the let's move ahead to the next step. Another good thing about Doubleword AI is typically works with the same OpenAI client, and all you have to do is to initialize the OpenAI client using the API key which we created from Doubleword AI, and then setting the base URL to the website, the V1 completion. Okay, by using client.files.create, you create this batch file. It's going to take a while because it has to create this batch file and then upload this batch file to Doubleword.ai and create a unique file ID for this particular batch. Let's wait for the completion. Okay, so the step has been completed. This step took around 1 minute and 20 seconds, but it highly depends on your internet speed, as because it has to upload this 200 MB file to Word AI batch server and then create a unique file ID for you. Once that is done, all you have to do is to use client.batches to create. Another option is to go to the Doubleword UI website. You can click on create batch and you can select your batch from here. So here, this is the exact file which we uploaded now. But if you want to do it programmatically, all you have to use is client.batches.create, pass in the batch file ID, and here you select the completion window. It can be either 24 hours or 1 hour. And the remember, if you're going to set it as 1 hour, it's going to have a little bit of more price than 24 hours, but it eventually it gets you the result much faster. So as soon as you run this, you can see that a new asynchronous batch has been created. And once you go to the Doubleword AI's website, and here you can look at the actual progress. So as we can see, it has already started to process this particular batch. Previously, I did the same step of 1,000 records. It took around 12 minutes to complete. And you can always check the status of batch using this method client.batch.retrieve of batch ID. Here you can by passing the batch ID, you can check the batch status, and here the batch status is in progress. As the batch is still running, it has completed around halfway through. I'm going to show you the output from my previous run. Here I did the same run for 1,000 invoice samples. And let's copy this particular batch ID and then paste it here to check the batch status. Okay, and then run this. Now here you see that the state is completed. It's because it's the previous run. From the batch status, you can get the output file ID. So this is the output file ID. And the way you download the output file is that you use this output file ID and then you make a request to the Doubleword endpoint. And for this, you need to provide the authentication by passing in the bearer token, which is our API key. We have already injected this in our environment. And then you use the request module to hit this URL and then download this batch output file. So the output here for this will be stored in batch output.jsnl. As a next step, let's go ahead and load this particular output, convert the output as a JSON, and then create it as a data frame. So here we can see that we have the output file. Okay, so we have written a small post-processing code which is going to iterate through each line in this JSONL file, retrieve the ID, load the response, and try to convert this response into a dictionary, and then save the response as a pandas data frame. So at the end of this particular step, you'll see that you have the index and you have the response, which is from the Quen 235 billion parameter model. Now that we have this information, it'll be cool if we can merge the ground truth as well. So that is the next step. So we already have the ground truth information from our original data set. So I'm just running a simple Lambda function to retrieve this GT parse, load it as a dictionary, and then create this data set DF. Here you can see that So this is our ground truth information where we have the index and we have the GDPRs. We can merge both of this together. Now that we have this information, it's much easy to compare this information and then uh, have the metrics generated. For that, I'm going to use a couple of utilities. A simple utility to um, calculate invoice level accuracy. We have done all this before in our invoice processing example. And once I invoke this, calculate invoice accuracies method, it returns data frame with the invoice number, and this is the total number of keys matched between the request and the response. Okay, and let's also look into the batch level metrics, which is auto generated. Here we can see that we had 1,000 requests, and all 1,000 were completed and zero failed, right? And then this is the total number of prompt tokens, almost 3 million prompt tokens, and here you can see that this is the number of completion tokens, which is 0.18 million, and then this is the total tokens as such. And if you look at the cost for processing the entire set of 1,000 samples, it costed less than 50 cents, which is really, really, really great, right? Our batch got processed within 12 minutes, but yeah, it is not guaranteed. The SLA is 24 hours, and then, of course, it was much faster. It got over within 12 minutes, but the guarantee is that it will get completed within 24 hours, right? If you want quicker results, maybe you have to schedule it with 1 hour window. And here you can view your input file, view your output file, and a lot of different metrics. You can view your results as well, right? Once you click on this, you can look into your actual result, right? It's in JSON format, right? And then you can download your output file from here as well. Doubleword.ai kind of makes this process super simple. By all these utilities, all you have to do is to build your batches and upload your batches into the website, and rest of it is taken care of. And with respect to cost, it's much more cost efficient than renting a GPU and then running your loads. If I said before, if you're an individual where you have a lot of data set to be benchmarked, and you can wait for the results, I guess it's one of the interesting option to explore. And for the enterprises which has huge loads, I guess once they expand with couple of other models as such, it will be a great option to try out with. I hope you have enjoyed this series. Do try out WWDI and let me know your comments. If you have any questions, feel free to drop in the question in the comments and try to answer as quickly as possible. And thank you very much for your support. Do like and subscribe to the channel. See you in the next video soon.